investigation of quadratic functions in vertex form, we want to end up graphing quadratic functions, and we're going to begin with stretches and reflections. However, in order to do that, we need to investigate the parent or base graph of the quadratic function f at x equals x squared. And if we create a table of values, I chose the values -2, -1, 0, 1, and 2 for my x values, and I could just substitute those values into the equation f at x is x squared. So when I plug in -2, it's in brackets, the whole thing is affected by the exponent, and a -2 times -2 gives me +4. Similarly, -1 squared gives me 1, 0 squared gives me 0, 1 squared is 1, and 2 squared is 2. So I end up with 5 key points to graph any quadratic. So when I graph a quadratic, I'm always going to start with my base graph and plot the points -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So that's what I'm going to do here right now, is I'm going to graph that -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Then I'm going to draw a smooth curve through my points. Don't forget to put arrows on the end because, of course, we've only plotted a few points on the quadratic function. You'll also notice that each point is symmetric about the y-axis. So if I look at this point, it's 1 away from the y-axis. This one's also 1 away. This point is 2 away from the y-axis. This is 2 away. Or it's also the same distance from the axis of symmetry. So for this function, the axis of symmetry is x equals 0. And in particular, for this function only, we could call that the y-axis. Our vertex is 0, 0. Our intervals of increase, if I look here at this point 0, 0, 0 is the vertex. The function's not decreasing in value or increasing in value, but it does increase to the right of the vertex. So we say x belongs to the set such that x is greater than 0, and it passes through all the values, so it's an element of the real numbers. For the interval of decrease, however, we're going to change that to a less than sign because the y values are getting smaller to the left of 0. And it passes through all the points continuously, so we also say it's an element of the real numbers. For the domain, we're not dealing again with ordered points, so we're going to start with x such that if I look, my graph continues off to the left, it continues off to the right, it's going to pass through everything, so we just say it's an element of the real numbers. And for the range, there's the smallest value. Y can't go below 0, so I have to tell it y has to be greater than or equal to 0, and then it's an element of the real numbers. And that's it for today. And the really nice part for you is I'm not giving you any extra questions to work on tonight. So enjoy your evening.